So, welcome everybody to another episode of Software Architecture on Stream. This time around in English, as you can probably tell. And our guest is Rebecca Parsons. So I'm glad to have you here, and it's an honor to welcome you on the show. So Rebecca, do you want to say a few words about yourself, what you're doing, and what your background is?
Sure. Thank you. Thank you for having me. Well, I actually started programming when I was about 13 years old and fell in love with it from a very early age. And I've had what some would refer to as a rather checkered past. I don't know if that particular saying translates well in German, but I've worked for a manufacturing company, for a computer company, in startups, for government research and academia. I've worked for the last 20 plus years now at Thoughtworks as a consultant. So I've seen lots of different aspects of the software industry over a period of time, and I have a particular interest in architecture. I did my doctoral research in parallel and distributed computation and programming languages, and so I guess I have a rather eclectic set of interests within the technology area as well.
Yeah, that sounds really interesting, and I'm glad to have you on the show with so much experience and such an interesting CV. So, what we are going to talk about is evolutionary architecture, and as a matter of fact, the reason why we are even talking to one another is that you are doing a keynote at the Software Architecture Gathering, and the guys from Software Architecture Gathering were so kind to put us in contact and allow us to have you here. And in your abstract to the keynote, you say that you're referring to agile processes. So one, I don't know, provocative question would be, so if you're agile, why would you even have software architecture? Because, you can't be sure about anything, and if there is anything that we learn, then we can just react to it in an agile manner. So, and architecture is so very, inflexible. So why would you have architecture in an agile process?
Well, I've actually spent a lot of time thinking about the role of an architect with respect to the agile software development process. And one of the things to realize is that a software development team has a very clear objective: get features out as quickly and efficiently as possible. And it's very much a short to medium term perspective. They have a business stakeholder that wants to get something accomplished, and that's their goal. But when you step back from it, an architect is responsible for the overall enterprise value of the full IT estate. So the architect's time scale is more long-term to possibly medium-term. And so there are aspects of building a system that will impact the medium and long-term viability of the entire IT estate. And somebody's got to worry about that. It doesn't matter if you've got this wonderful little, agile delivery engine that can efficiently and quickly get out business features, because you've got all of these other considerations: resiliency, the ability to operate, recoverability, emerging standards around privacy or security. And so there are these concerns that are shared outside of a delivery team. Now, this is not to say that I believe that architects should sit off in their little corner, and rule on their subjects. But architecture is still important from the perspective of an agile project. You have to decide, what are the things that matter from an architectural perspective? What are going to be the critical success drivers? And if you don't understand those, you're not going to be able to make the right kinds of decisions as you're faced with not only changing business requirements, but changing environmental and the technology ecosystem as those changes come into being.
Another thing that I noted when I was reading your abstract is that you were referring to patterns, and patterns seem to be sort of an old thing. So back in the 90s, there was obviously the Gang of Four book about patterns, but that's on the code level, and that's quite long ago. So how are patterns relevant to modern day software architecture, in your opinion?
Well, think about the two books from the early 2000s, the patterns of enterprise integration architecture, or integration architecture patterns by Gregor Hope, and of course the patterns of enterprise application architecture that Martin Fowler wrote with a couple of thought workers. What I see when I think about evolutionary architecture is an expansion, if you will, of the notion of patterns as ways to solve for different architectural concerns. You can think of a kernel-based architecture as solving one particular kind of architectural problem. Microservices is another architectural pattern, hub and spoke. So there are lots of different architectural patterns that you can think about. And if we talk about them at the pattern level, you can start to see how those different characteristics impact different architectural requirements. How one particular architecture might in fact be more resilient or more scalable. And so that's why I think patterns are important to talk about architecture, is you can abstract away from some of the nitty-gritty details of the implementation and say, what are the trade-offs I might need to make between, high throughput and security, or how might I address my problem of scalability or elasticity.
And you did write a book about evolutionary architecture together with Patrick Cour, and actually we did an episode with Patrick not too long ago, I think by the beginning of this year, and Neil Ford. So is that book a collection of patterns? Is that what it is? Or do you use that at all?
The patterns language really has evolved a bit later. And in fact, later this week, Neil and I will be talking about how to approach a second edition of the Building Evolutionary Architectures book. And I suspect that is going to figure a bit more prominently. But the notions of evolutionary architecture actually take a lot of inspiration from another one of my favorite research areas, which is evolutionary computation, and specifically genetic algorithms and genetic programmings. And what a lot of the book is about is this notion of a fitness function, where you will specify for your architecture, these are the architectural characteristics that matter. This is the level of scalability that I require. This is the level of robustness. How many nines do I need? How many concurrent users? What are my security requirements? What are my observability requirements? And that's a lot of what the book is talking about, is how we translate what we want our architecture to achieve into a fitness function, so we can actually figure out, have we achieved it? And do we continue to achieve it over time? Because that's one of the things that many architectural processes don't do a good job of, is how do we know 6 months or a year down the line that those architectural characteristics that we wanted in a system still exist? And that's what the fitness functions are all about.
Yeah, so sort of the obvious follow-up question would be around the fitness function, but I really want to spend a few minutes about something that you just mentioned and that might not even be known to everyone, and that is genetic programming and genetic algorithms. That's because I did a diploma thesis about it. So can you say a few words about that and what this area even is? Because I think it's so very fascinating, and there are not too many people who even know the term, I guess. So at least we should explain that on that level?
Well, I got involved with genetic algorithms to work on a problem that was obsoleted by new molecular biology technology. But I was working at Los Alamos National Laboratory on the Human Genome Project. And at that time, the sequencing technology was such that you couldn't sequence much more than, say, 5 or 10,000 base pairs reliably. And of course, that, the human genome is massive in comparison to that. And so we had what was called the fragment assembly problem of, they would do the sequencing by replicating the bigger genome, randomly chopping it up into lots of different pieces, sequencing all the little pieces, and then you had to put the jigsaw puzzle back together. And people had used techniques like simulated annealing and some more traditional optimization techniques. And I was working with a molecular biologist at Los Alamos, as well as with Stephanie Forrest from the University of New Mexico. And it's like, well, let's try a genetic algorithm. And basically with a genetic algorithm, you have a fitness function that tells you what constitutes good. And it's actually easiest to explain this using a more traditional computer science problem. So we'll use the traveling salesman problem. So in this traveling salesman problem, you have a list of cities that the salesperson has to navigate, and you want to order those cities in such a way that the salesperson will visit them all, but in the shortest distance. So that's a very obvious fitness function. Given a list of cities, does it visit all of the cities, and what is the distance? And you want to minimize what the distance is. So in a genetic algorithm, the fitness function is really what's driving it. But then you have other operators that sit around it. You have to decide how to represent your problem in something that is effectively just a string. Well, in the traveling salesman problem, that's easy. It's, the cities in order. Then you have what's called a crossover operator, because genetic algorithms are inspired by biological evolution. And so you will take two possible answers and use a crossover operator, which is just some way of taking two and mushing it into one. And then you'll have a mutation operator that might make a random mutation somewhere. So in the case of traveling salesman problem, it might swap two cities. And then you select your new generation on the basis of the fitness of all of the individuals that you generated on the basis of your crossover and mutation operators, and using that fitness function as a way of regulating the percentage of population of various kinds. And genetic algorithms have been proven to be actually quite effective at solving many different optimization problems.
Mm-hmm. And that's, I think, why it's so very interesting, because it's so clearly modeled after the biological role model, and it's so very close to it. And as you said, it is quite successful in particular in complex areas. So what is a fitness function for a software architecture then? So, because you just said, okay, for the traveling salesman, it would be, are all cities visited, and how long is the path? So what is a fitness function for a software architecture then?
Well, there are a wide variety of fitness functions. For example, it might be, I have a performance requirement that says that, all screens have to respond in less than a second. So that would be a fitness function, and you would run that against the performance, all of your different screens, and say whether or not it matches. Or perhaps you have, you need to be able to deal with 10,000 simultaneous users with performance no less than this. So that would be another fitness function. Actually, one of the most interesting fitness functions is Netflix Simian Army. Netflix has this whole range of monkeys, chaos monkeys, that basically just go in and disrupt things to see what happens. But they also have, for example, particular parts of the simian army that will check to see, is your RESTful endpoint properly configured? That is a fitness function. If you are querying a RESTful endpoint, if it isn't properly configured, it's pulled out of the ecosystem. So fitness functions within software and architecture are not new things. We're just taking this notion of a fitness function, applying it to many of the kinds of tests and metrics and other measures that we put in place for software to help reinforce the idea that this is where we're defining what good looks like. What are the important outcomes or behaviors we want our system and architecture to exhibit for our users and for the people who are running the application? And so our target architecture moves from being some big block diagram hanging on the wall to this system. It's effectively the composition of all of the individual fitness functions where you've encoded these are the architectural outcomes that I want to achieve.
And would each of these, so you were talking about response times and these kinds of, as an example, and these can be translated to some tests, like some performance or load tests. So would each part of that fitness function be translated to a test in the ideal world, or is it even translatable?
In an ideal world, all of the tests would be automated, yes. All of the fitness functions would be automated, but some of them you may choose not to. And so the key point about a fitness function is less about whether it's automated or not, but more that you and I will never disagree on whether or not a system passes. So saying the code must be maintainable, that is not a fitness function. What do you specifically mean by maintainable? A fitness function might be cyclomatic complexity no greater than 30. It might be adherence to a particular coding standard. There might be other measures of software quality having to do with coupling or length of classes, those kinds of things. That's the important characteristic of a fitness function, is you are specifying this is specifically what it means. And therefore, you and I will know whether or not our particular system is exhibiting that characteristic, because it is unambiguous. Just like the change we made with Agile software development is the users were in control of the acceptance tests, but it had to be unambiguous. There couldn't be this, oh, well, yes, a test passes the test. Well, no, it doesn't. You should not ever be in a situation where you disagree on whether or not that fitness function has been fulfilled.
And talking about acceptance tests and the customer role, so would the fitness function also be something that I talk to the customer about, the customer role about?
It depends on what aspect of the architecture that you're talking about. Many of the fitness functions are more about the architectural ilities, so performance and load and scalability and all of that. Accessibility, though, would be a major source of fitness function requirements, and there may be others in terms of usability, and so those might be things that you might test out with the ultimate end customers. Again, a fitness function that says the system must be usable is not terribly interesting. But if you use the drive for usability to start to have a conversation on, okay, what does that mean about where I place my buttons and what size the font is and how does it respond, as you move from, a mobile phone to a tablet platform, all of those kinds of things. Yes, those two can be thought of as fitness functions.
Excellent. So we had a meeting to prepare this interview, and during that meeting you said that fitness functions are also important for architectural governance. So what is architectural governance and how is a fitness function related to architecture governance?
Well, if you look at the way architectural governance has traditionally been done in the past, it was very implementation driven. This is the set of tools that you are going to use. Not why you might use those tools, but this is the set of tools that you will use. And it was very review driven. Okay, I need to sign off on your component diagram, or I need to sign off on this or that. One of the things that we've learned over the 20 some odd years of Agile is to start to think about how can we speed up these processes. And so if you have, for example, a coding standard, no cyclic dependencies. Well, why in the world would you do a manual code review to look for cyclic dependencies when you could just as easily put a syntax check into the build that will fail the build if there's a cyclic dependency? Now, the advantage of doing governance through things like these fitness functions is once you put that in, no one ever has to think about a cyclic dependency again, or a cyclomatic complexity that's 140, because the build fails. And so the more the governance can be encapsulated in these fitness functions, and in particular fitness functions that help us understand what's the outcome we're trying to achieve, the more governance can be done that way, the more first you free up the time of the architects to do things that require brain power. Okay, well, I need to have this level of responsiveness, so I'm looking at using this caching strategy, but using this caching strategy violates our staleness requirements for security. How do I balance these things? How might I solve this problem? Those are the kinds of things you want your architects thinking about, not doing a desk check to see whether somebody's introduced a cyclic complexity, a cyclic dependency. So that's the first advantage of governance through fitness functions, is you're freeing up the time of the architect to do much more value-added work, as opposed to manual checks that could just as easily be automated. But the second advantage is one of the things that we're trying to do is move away from a focus on implementations to a focus on outcomes. I want you to achieve this level of scalability, not you will use this approach to scalability. By shifting it to the outcome, that allows the delivery teams to potentially take advantage of technological innovations that might make it much easier to achieve that level of scalability. And they shouldn't have to consult the architects if they're achieving the outcome. Now, yes, there's probably something around technological sprawl and all of that kind of stuff. And we've seen both the advantages of anarchy and letting people do whatever tools they want to do, as well as something that's just so locked down that the people can't make the right choices. Obviously, you still have to manage that. But if you start to focus on, this is the outcome I want to achieve, this is the desired behavior, then the development teams can start to take advantage of innovations that are happening in the technology ecosystem to say, I can do this better. I can make this more supportable. I can lessen the strain of getting the level of scalability if I can use this particular technology.
Now, what we are discussing is actually evolutionary architecture. So what you said is that the fitness function would help to sort of let teams self-organize and to have unambiguous goals for the project. But how is it relevant to evolutionary architecture?
Because it provides the guardrails for decisions that are made. If I'm looking at a particular approach to one of my architectural characteristics, and I can't meet my fitness function, that tells me I've got to come up with a different approach. So we're using these fitness functions as a way of ensuring that we have the architectural characteristics that we've decided are important for this particular application, and that those don't degrade over time. Because that's what very often happens is as systems evolve, sure, they get deployed to big fanfare, and then new features start to come in and things start to get more brittle and it takes longer to change things. And, the fitness functions are there as the guardrail to say, no, you can't make that change because you've now broken one of the architectural outcomes that has been deemed important. And that's the role that fitness function plays, is it guides. So the actual definition for an evolutionary architecture is that it supports guided incremental change across multiple dimensions. And this guiding is what the fitness function does. You say, these are the architectural characteristics that matter. And one of the examples that I very often used early in my Thoughtworks career, I worked on a trading system. People hear trading system and they immediately think high frequency trading. High throughput, low latency performance is absolutely critical. For this trading system, they only made about 100 trades a day. They didn't care about low latency. They cared about never, ever losing a trade because each one was worth billions of dollars. What constitutes good for that trading system that I built is completely different than what constitutes good for a high-frequency trading system. We made very different architectural choices. We put our effort in very different places from the perspective of our architectural decision-making, because what we needed, the architectural characteristics and behaviors we needed from that architecture were completely different from that other architecture. There is no such thing as this is the perfect architecture for all applications. It doesn't exist. Security matters more or less. Performance matters more or less. Uptime matters more or less. We're constantly having to make these trade-offs. And to do that, you have to have a specification of this is what good looks like for me.
And what you're saying is that this trading system would still, up to this day, hopefully still fulfill the fitness function that was initially defined, even though it might look completely different now and the architecture and the implementation might have changed.
Exactly.
Okay. There is another thing that we discussed right before this interview. So, and I found that interesting too. So why is it called evolutionary architecture? Why is it not called adaptable or flexible architecture? Because at the end of the day, what we are aiming for is probably a flexible architecture, right? Or is it not?
Yes, but when Neil and I first started talking about this many years ago, I heard him give a talk, and he actually called it an emergent architecture. And I told him that I thought that was a very bad name, because emergence doesn't really give you that same flavor of guided. I don't have a way of saying, in my case, this is what good looks like. I'm perfectly comfortable with people talking about emergent design, because bad code is bad code, whether it's in the finance domain or whether it's in the retail domain, or whether it's doing climate modeling. Bad code is bad code and good code is good code. And we pretty much all agree what constitutes good and bad code, and it doesn't really vary very much. And that's why I liked evolutionary, because of this fitness function notion. But adaptable is one that we actually talked about. And the problem with adaptable is people immediately go from adaptable to adaptor. Okay, so I know the kinds of changes I'm going to have to manage. Maybe I want to be able to swap out my persistence layer. So I'm going to, build a layer in there so that I can swap out databases, or I can swap out my queuing system, or, but I know where the change is going to come from. The problem is you don't. We don't know where the change is going to come from. And so if you try to build these adapters when you don't know which ones you're going to actually need when, what have you done? You've written more code, so you have more bugs, because we all know that the number of bugs is directly related to the number of lines of code. If you've actually built an adapter for something you don't need, you've made that thing more complicated than it needs to be, so it's harder to understand. And there's a really good chance you've made it harder to make the change that you actually have to make because you built this adapter that you don't need. And so we wanted to really drive home that you can't predict where these changes are going to come from. And if you can't predict where they're going to come from, you can't make it adaptable. Flexible has much the same problem as emergent, because it's just saying, okay, I need to be able to respond to whatever. And it still doesn't have that notion of what does good look like for me in my trading system versus what does good look like for this organization over here with a high frequency trading system versus this retailer over here who has a completely different set of business requirements and probably cares a whole lot more about what happens on Boxing Day or Black Friday. Well, a high frequency trading system doesn't care about that. The markets are closed. So, you've got all of these different pressures on what's a good architecture for here, what's a good architecture for here, what's a good architecture for here. And that's what Evolutionary captures so much more than any of those other names.
Mm-hmm. I found it interesting that you were just saying that, when you build in some flexibility, it's probably not going to be at the place where you really need it. However, if I talk to customers, I often have the impression that they think, well, we can sort of predict where the change hotspot is. So let's imagine that you're consulting me and I'm an architect at some customer, and I'm telling you, okay, I know that this needs to be flexible because this is a change hotspot, and I know that this will happen in the future. This is what's going to take place. So I will build in some flexibility here. What's your answer to that? Is it you ain't gonna need it, or what? How would you tackle that problem?
I'm a consultant, so I'm going to say it depends. But what it depends on is what is the basis of you knowing that? If you have a particular, let's say you're using a particular middleware product, and you know what their product roadmap is, and you know that there's something coming on their product roadmap that is something you're going to want to take advantage of. Absolutely. Make your architecture adaptable to take advantage of that new feature once it comes, because there's a really high probability that that's going to happen. But in some of these other cases, one of the examples that Neil likes to use a lot when we're giving a public talk, I will bet anybody in the room 100 of whatever currency you have, if you can guarantee to me what JavaScript framework you will be using in 2 years' time. And that's what people do. They laugh. Of course you can't do that. It hasn't been written yet. How can you predict how to make your front-end architecture adaptable to take advantage of a new framework, and you have no idea what it's going to look like? You have no idea how it's going to differ from the one you're using right now. So how do you take advantage of that? Certain things you can know, and it's actually a very similar argument to the Yagni articles of old. The you ain't going to need it. Well, I don't know in this particular story yet that I'm going to have to talk to the mainframe. So why should I even think about talking to the mainframe? You know, your downloads are going to come from the mainframe. You know, just because it hasn't appeared on your current story list doesn't mean you don't need to think about the fact that this stuff is going to come down from the mainframe. There are certain things that just professionalism dictate that you pay attention to. Oh, well, I don't know that there's going to be multiple stores, so why don't I hardcore the number of stores at 845? No, you're not going to do that. You're going to put it in as a symbol. Those kinds of things, you'll see the same thing at the architectural level. There are some are going to happen, and certainly build to anticipate those. But don't try to get out, your crystal ball or your Ouija board or whatever and figure out, okay, this is when this next revolution in how we interact with computers is going to happen, and therefore I must be ready for it. Mm-hmm. We can't do it.
So we spoke about the fitness function and what evolution, like what the goal of an evolutionary architecture is and why it's called evolutionary architecture. How would I make my architecture evolutionary? What are some basic techniques to sort of make it happen?
Well, generally I talk about 4 sample techniques. And to me, one of the critical enablers for evolutionary architecture is continuous delivery. I mean, when I first started talking about evolutionary architecture, people would come up to me, and they'd whisper after my talk, "Don't you think you're being professionally irresponsible to talk about changing architecture? Architecture is the rock, it's the foundation. How could you evolve the foundation? It must be," and they get all worked up about this. I don't get that reaction anymore. Very often I get, I know I need it, I just don't know how to do it. So similar to your question. But one of the things that makes it possible are the disciplines and the underlying techniques and approaches that come from continuous delivery. Because the people who were saying, this can be disruptive because architecture is defined as the things that are hard to change. It can be pretty disruptive to make some of these major changes. And so you want to have the utmost confidence that you know exactly the environment that you're deploying into. You know exactly that things are properly configured so that you can focus your attention on, have I done something wrong in the change that I know I'm making, as opposed to something that is completely unrelated. And we've all been through deployments, in the past where, it's that sigh of relief. Oh, I didn't get yelled at by the CEO this time because we actually managed to get it out without the system collapsing around our ears. And we would celebrate more the fact that the deployment didn't fail than the features that we actually deployed. That would come when we actually got some sleep. And so continuous delivery is one of the important underlying foundational techniques, because you want to be able to focus your attention on, these are the things that are going to be impacted by this change. Mm-hmm. A second important enabling technique is the ability to refactor databases. I've been involved in the Agile movement for a long time. And, people would say, well, it's okay for the developers, but, I'm a QA and I can't test everything until everything's done. I'm a business analyst. I need to be able to lay out the entire map of the user journey before we can get started. And role by role by role, all of them started to realize that You can't know everything up front. Something is going to change. I'm going to have to figure out how to be able to introduce new things into my process. So how can I actually go ahead and embrace the fact that this is going to change? The group I've always had the most sympathy for is the DBAs. Because the minute a database is in production, you can't change that database without doing a data migration. And data migration is hard. Conceptually, it's easy. What could be harder? You copy it from this to that. What could possibly go wrong? It always goes wrong. And much like code refactoring, and I'm using refactoring in the precise term, which is those small changes, the database refactoring approach said, we're going to take those large schema changes and decompose them into the atomic changes that are necessary. And for each one of those changes, you also introduce, and here's how I migrate to just support that change. Now, that doesn't mean that all those little data bombs from 1984 aren't still there, but it's a whole lot easier to find them when you are looking at the migration from the perspective, I'm making this one change. So what is this one, adding a new column or splitting a column? How did that go wrong with this data element? And so it simplifies data migration. And you cannot evolve a system if you can't evolve its data. Mm-hmm. And so to me, that's a critical technique for evolutionary architecture.
I want to spend a few minutes on this because I think this is really interesting. So first of all, if I understand you correctly, what you're proposing is the fine-grained refactoring approach that the original refactoring book also spoke about, but this time around for databases. So like adding a single column, or I think your example was to split up a column or things of that nature.
Mm-hmm. Yes.
Okay, so I mean the refactoring on the code level to me is something where I would do, I don't know, lots of refactoring every hour. It's a continuous process. Mm-hmm. That's sort of yes. The core. And in particular for databases, there is this school that says, I think it's from Etsy. We take 1 week of 1 day of the week, and this is where we are going to roll out the next evolution of our database schema, which basically means that you pile up the changes over a week, and then you do that one change because it's so risky to do the database changes. So, and that's a different approach. So, are you proposing this fine-grained refactoring approach with many changes every day, hour on the database level in production, or are you rather on this Etsy side where you would do that one change, that one pile of changes, I should say, every week?
It's more towards the Etsy approach, and let me be clear. There is a book called Refactoring Databases with the subtitle Evolutionary Database Design. It's over 10 years old, but it's still a completely unappreciated book. It was written by my colleague at Thoughtworks, Pramod Sadalgi, as well as Scott Ambler, who at the time was with IBM. We keep telling Pramod they need to re-release the book and swap the title and subtitle and call it Evolutionary Database Design and then Refactoring Databases. But the beauty of that book is really that it focused on the problems that database administrators and database specialists were actually having, which is you can't go willy-nilly changing the database because we have to do the migration. And so it focused really on the very real problems that were the case at that time. And so I would definitely encourage anyone, if you're having this problem, go out and buy that book.
Yeah, and I will definitely put a link on the show notes, because I actually bought that book at one point, but I should probably also reread it. Okay, so what you're saying is you would still pile up some changes and do them like weekly or daily or whatever. What's the third technique that you propose?
So this one is a bit more controversial. If you look at the way different parts of a distributed architecture work together, you have two major choices. You can go with an orchestration approach or a choreography approach. And the way I explain this, if you think about an orchestra, there is a conductor. And the orchestra does exactly what the conductor tells it to do. Everybody's paying attention to that conductor. You have effectively a single point of failure. But there are errors that will never happen in an orchestrated system. It's the orchestrator's job to handle all of these different kinds of problems. Whereas for a choreographer, again, think about a dance performance. The choreographer is not out there when the company is performing, telling everybody where they need to go. They all know what they're supposed to do, and they know that they might have to respond to something that happens. So I'm supposed to leap gracefully, and somebody's supposed to catch me, but he trips and falls onto the floor. Well, I'm not going to leap expecting him to go ahead and catch me because he's flat on his face. So I'm going to do something that will allow me to get to the next place that I know I have to get to. You distribute control, but when you distribute control, the advantage is now I can move those pieces around because each piece really knows how to do its thing regardless. But I pay a cost in significantly increased complexity because now each of those individual performers need to know what to do in all of those different error scenarios, where if there's an orchestrator, the individual performers just say, something went wrong, please tell me what to do now. All of that error handling is centralized. So you get a lot more flexibility in a choreographed architecture, but you pay a significant cost. Depending on what your other abilities are, you might decide that that level of evolvability is simply not appropriate for you. But when we think about evolutionary architecture, we are looking at all aspects of the architecture. How are you breaking things down into components? How are those components communicating and coordinating their activity? What is the data architecture and what are the requirements for data consistency and transactionality? All of those questions come into play, and you might decide, even though I could keep these things very loosely coupled, I have to change them at the same time anyway. So I might as well more tightly couple them to make my performance targets easier to meet. So evolvability is another one of those abilities that you might have to trade off, like with performance, like with scalability, all of those different things. What is most important? And something like choreography is a technique that you may not want to use because it's too complex and it's not worth paying the complexity cost to get that level of evolvability that maybe you can get some other way. Mm-hmm. So there's another example.
Yeah, I think it's very interesting because I think oftentimes people have this tendency to think about end to end. I think you already mentioned that, like business analysts that say, okay, we need to roll out this huge map about everything, and it's really, really complex. And choreography might be one way to battle that, right? I think that's maybe one aspect there.
Yes.
There is a question by Dude on YouTube, and he or she says, what about the fact having the database migration as part of the feature? release often. So I guess what that person's asking is whether if you release a feature, you should have sort of a database migration script that says, okay, this is how we are going to change that database once we release that that feature. So would that be an approach that you would think is advisable?
I would still decompose whatever those changes are into those atomic pieces, particularly if you're dealing with a database that's been in production for several years, because data does not age well. But that is really one way to think about it. Okay, this is the change I need to make for that particular feature, and conceptually, what you do is you decompose whatever that schema change is into the component parts, and then you just compose all of the changes and compose all of the migrations and run that. But yes, or organizing it around the feature is certainly one way to think about it.
But if I understand you correctly, what you're saying is it should be more fine-grained. It shouldn't be just one script for one feature, but it should be a more fine-grained than that.
You might still have one script, but within that script, you would want it decomposed so that you could identify what aspect of the change might have caused that migration to fail. Because that's the real sticker. Is I've got 200 million rows, and I run the data migration, and I get 150,000 failures. Okay, where do I start?
Yeah.
Whereas if you decompose it, yes, you're still going to have that same 150,000 failures, but you're going to know, okay, these 10,000 relate to this part of the change. Okay, what's this part of the change? What could have gone wrong? Sample a few of them to look at, figure out what the patterns might be, and then figure out how you have to fix the migration for those 10,000. And then you go on to the 15,000 that failed on this stage, as opposed to trying to deal with all 150,000 at once, where you have no idea why they failed, just that it didn't work.
Great. So those were 3 out of the 4 techniques. So what's the 4th one?
The final one that I talk about, and there are more than 4. I'm trying to pick ones from different parts, is to think about contract testing. Because one of the things we're trying to do in an evolutionary architecture is to support as much independence as possible. So let's say you and I and Neil all rely on each other to some extent, but we're building independent services. So I'm going to give you and Neil an acceptance test that documents the assumptions I'm making of you. And you're going to give to me and Neil's, and then we start ignoring each other. I'm running your tests and Neil's tests. You're running my tests and Neil's tests, and everybody's happy, and we're completely ignoring each other. It doesn't matter what kind of change we're making, we're completely ignoring each other. And then your test that you gave to me breaks. That means that I'm trying to make some kind of change that is going to alter the contract I have with you. Neil's test is still running. So we both still continue to ignore Neil. We have a discussion on how I can achieve what I need to achieve while still satisfying your assumptions. We make whatever changes are necessary, re-exchange tests, and we go back to ignoring each other. And Neil has never even had to talk to either one of us. These contract tests have the additional advantage of effectively documenting what are the assumptions everybody is making about everybody else. And that's what some of the best enterprise architects I ever knew, that was their real value, is they understood how information flowed through the enterprise, the assumptions that different systems made about each other. They understood all of those things. By getting those into code, getting those documented, you're taking away that single point of failure of what happens if that architect leaves. because all of a sudden, all of that institutional knowledge would just go away. But from an evolutionary architecture perspective, it allows us to work completely independently, evolving ourselves and knowing, okay, now I need to go talk to Eberhard because his test is just broken. And so I know I have to talk to you. We both know we can continue to ignore Neil unless what we come up with happens to break Neil's tests for one of us. And then we have to bring Neil into the conversation. Mm-hmm. But it allows the maximum amount of independent work. You can evolve things as is appropriate for your system, safe in the knowledge that I'm going to continue to be perfectly happy with what you're giving, regardless of what changes you are making. So it increases your scope to be able to change things however you want by having these strong contract tests.
I like how those different techniques are actually on very different levels, and some of those parts are not something that you would probably consider architecture, when you think about it in traditional terms. One thing that I would also be interested in, oftentimes there is this sort of tension between the technical people and the business people, and business people don't really see why you would invest in a clean architecture, or an evolutionary architecture or architecture at all. So what's your take on that? How would you try to approach that problem? Or what advice would you give with this in this regard?
Well, there's two different sets of advice, and I'm going to start with, you have an old crusty architecture and you're trying to convince somebody to let you improve that architecture, because that's really the harder of the two problems. If you're starting with a green field, you have to do something. You have to make decisions, and it's usually not too hard to convince people to let you make good decisions if you're starting greenfield. So it's normally the brownfield that's the problem. And one way I approach this is to talk about, the decreasing the cost of change and the time to market. Because one of the things that we have seen over the years is this increasing expectation from our business users that our systems just aren't changing fast enough. And it's like, okay, well, if you wanted to change fast enough, you have to give me the opportunity to invest in it. And these are the ways, this is the strategy that I'm going to use. Now, a big problem in that conversation is usually the fact that a few years ago they said, okay, we're going to, give us, 3 months, and we're going to clean up the architecture. We're going to clean up the code, get rid of all the technical debt. And so they got the 3 months, and now they're back saying, oh, it's a mess again. This is where the fitness functions come in, and in particular, the disciplines of introducing these fitness functions into continuously monitoring the adherence of the system to those fitness functions. Because I can say, if you let me clean it up this time, it can't ever get back into this shape, because I'm going to break the build if somebody starts to violate our layering. And I'm going to break the build if somebody gives me this monstrosity. And I'm going to break the build, And so you can demonstrate that you have the governance through the fitness functions to ensure that this never goes wrong again. The other part of making this argument is to focus where the pain is the worst, not where the worst problem is, but where the pain is the worst. And you can usually get some quick wins that demonstrate to your stakeholders, okay, this problem actually can get better. They just took away this significant source of pain from me. So those are the two pieces of advice. Use the fitness functions to ensure to reassure your stakeholder, we can't backslide. This isn't going to happen again. And then find early pain points that you can address and show some early progress.
Excellent. I'm afraid we are a little bit, we are almost done concerning the time, but there is still one question from about the contract-driven, consumer-driven contract testing, the contract tests. And the question is, how do you deal with versions of contracts if the other part is evolving faster? So there is one part that does some changes and the other one is not there yet.
Well, what these tests tell you is when there's a problem. So it may be that your ability to evolve your system is significantly greater than mine. And so you've come out with lots and lots of do them. But as long as you're giving me tests that still pass for me and my tests are still passing for you, the fact that you're evolving much more quickly isn't a problem. Where we get to the problem is, okay, now something that you want to do breaks one of those tests. And I can't solve that problem. At least we know that now we have to have the conversation. There may be workarounds that we can put into place. Maybe you can keep the old service running for me longer and do a parallel run. But it may be the case that you have to slow down because something has to be fixed on my side and I'm just taking longer. I can't fix those problems. But at least we know the problem is there and we know the source of the problem so that we can come up with a strategy to mitigate it.
Okay. So one final question. So what would be the one advice that you would give an architect? If there was just one advice that you could give to him or her.
One of the most common problems I see with architects is they still want to talk too much about the technology. And, sometime in the future, all businesses will understand technology and will have technologically savvy CEOs and CFOs and CEOs running all around. But for right now, architects need to speak a bit more in the language of what is the business goal of the organization. Because the CFO doesn't really care about some minutia on the middleware. They care about functionality. They care about cost. They care about our end customers getting what they need. So architects, for the moment, still need to be that communication bridge between the technology community within the organization and the business stakeholders. And we need to do a better job of communicating in their language, because we're not going to get what we want otherwise.
Yeah, I really like that advice. So thanks a lot. I'm really looking forward to your keynote at Software Architecture Gathering. And the organizers of Software Architecture Gathering were so kind to give me a discount code for 15%. That would be SAG21_EW_15. But I will also put that in the notes, and it's actually already in the chat. So if you want to see Rebecca's keynotes and all the other interesting stuff from the conference, feel free to register. Thanks a lot for joining. I really enjoyed the conversation, and yeah, I hope you have a great weekend and a great conference at Software Architecture Gathering. So thanks a lot.
Thank you for having me, Everhard.
Thank you.